Hello students, today we will discuss about bonding in organometallic compounds. Okay, for explaining bonding in organometallic compounds, we will take one very good and also first invented compound is Jesse salt. This compound is invented in the year of long back in the year of 1827 by Jesse. Okay, this is invented. That guy prepared this compound using potassium salt and ethylene molecules. Ethylene in presence of HCl. Okay, in this compound, platinum is a 4 coordinated compound. In this 4 coordination compound. In this case, 3 coordinated are come from 3 Cl chloride ligands, and 1 coordination is given by 1 ethylene molecule. It's a salt, it's a potassium salt. Now I will explain the bonding in GC salt. This actually 4 coordinated compound, 4 coordinated organometallic compounds. In this 4 coordinated organic compounds, platinum is in +2 oxidation state. Platinum is in +2 oxidation state. Now, in this case, is a square planar complex. Since it's a 4 coordinated, it's a square planar complex. The oxidation state, in this case, oxidation state of platinum is +2. Now it's a D8 system. In the valence shell of platinum contains 8 electrons. That is only D electrons. Now 6 electrons are come from 3 Cl items, Cl chlorine ligands, and 2 electrons are come from ethylene molecules. Now here 6 electrons plus here 2 electrons. Now in valence shell in these molecules, in these molecules, total number of electrons are 8 from platinum and also 6 from 3 chloride atoms and 2 from the ethylene ligand. Now totally 16 electrons. It obeys 16 electron rule. Now how the bond is formed between, we know the bond formed between platinum chloride using we studied all the crystal theory and valence bond theory and MOT. We can explain the bond formed between chlorine and platinum. Now what's the bonding between platinum and ethylene molecules? It's a coordination bond. There is a 3 coordination bond between chlorine and platinum. Here, what in this case is a different. Here, the in the beginning, the ethylene molecule initially gives 2 electrons, that is pi electrons to platinum. The pi initially donates this pi electrons to platinum. Okay, this is sigma bond. Sigma bond is formed between pi electrons of ethylene and platinum orbitals. Now these orbitals, the filled pi orbitals of ethylene molecules overlaps empty metal orbitals of platinum. Empty metal, that is empty d orbitals of platinum. That is sigma. There is a sigma bond formed between filled bonding filled orbitals of ethylene and empty orbital of metal. Now, in addition to, now during this formation of sigma bond, the electron density at ethylene platinum is increases, so that in order to stabilize, in order to get stability, platinum is losing excess electron towards ethylene molecules, so that your platinum metal donates its excess electron towards ethylene molecules, ethylene molecule. Now here initially the ethylene molecules gives its pi electrons to empty orbitals of metal, so that so that electron density of metal increases. In order to get stability, platinum again gives its excess electrons towards ethylene molecules, so it forms pi bond. Initially the sigma bond formed between filled pi orbitals of ethylene and empty d orbitals of platinum. In the next metal filled orbitals overlaps empty orbitals of ethylene molecules. So that in addition to sigma bond, there is a formation of pi bond in this case. Now here all three initially all square planar complexes are in single plane. Now especially all platinum complex are square planar complex, but this is sort is not planar, is a non-planar molecule. Non-planar molecule. Here all three atoms including platinum are in single plane. Whereas this ethylene molecules is present at perpendicular to this plane. Now all three and including platinum are in plane, but here this ethylene molecules is perpendicular to this plane of this complex. Now is how it will get stability, because it obeys 16 electron rule. That's why the valence shell contains inert electronic configuration. That's why this is planar. This is more stable compounds. I will explain again. This is initially it's a 4-coordinated complex, 4-coordinated organometallic complex. Because why it is organometallic means, okay, it contains three Cl minus 3 Cl ligands and also one ethylene. It bonded to one ethylene molecule. So it forms metal carbonyl bond. That's why it's a organometallic compound. So the oxidation state of this platinum in this case is +2. Now this is square, again it's a square planar complex, but it's not planar molecule. Why it's not planar means all three ligands, all three Cl minus ligand and platinum are in one plane, and whereas your ethylene molecules is perpendicularly plane of that complex. Now how it obeys 16 electron means initially at platinum there are 8 electrons, 8 d electrons. 6 electrons are come from 3 Cl minus atoms ion, then 2 electrons from ethylene molecule, so that total number of electrons present in this case is 16. Now how bond is formed between, we all knows how bond formed between Cl and metal, because it's a conventional coordination bond, whereas the how metal form bond with ethylene molecule is initially ethylene molecules forms pi bond with platinum. Then how it will form filled orbitals of ethylene, pi orbital of ethylene molecules overlaps with empty metal orbital of platinum, so that it forms initially pi bond. Whereas in addition to pi bond, this also forms sigma. In addition to in addition to sigma bond, it also forms pi bond by overlapping empty orbitals of ligand and field orbital of metal. It forms pi bond. So in order to get stability, platinum loses its electron towards ethylene molecule so that it gets stability. Now you say it's not a planar molecules because this ethylene molecules is perpendicular to the plane of this ligand, this complex. That's initially all platinum complexes are square planar, whereas this GC is not planar, is a non-planar molecule because it is ethylene molecule is perpendicular to the plane of this platinum and 3 chloride ions. So this is a non-planar. Okay, I will stop here. Next class next day we will discuss about more examples of organometallic compound. Thank you.